Hi friends, welcome to Stickontech. If you are new to the channel, please do subscribe and make sure the notification is enabled. Most of us are familiar with the popular development boards like ARDUINO UNO, Node MCU, etc. In this DIY session, we are going to make a development board with ESP8266 and some easily available electronic components. Before going to this topic, let's discuss about what is a development board and where it is applicable for. As the name itself, development boards are using for electronic project developments and experiments. A development board is a simple circuit made on a printed circuit board with a microcontroller or microprocessor and its peripheral components and circuits. The main use of a development board is to build and test our project concepts. For example, if you have a microcontroller and you are planning to build a project like motion detector, temperature alarm, or planning to test a sensor like PIR or ultrasonic, then you have to set up all the circuits and hardware on your breadboard or common PCB each time. Obviously, this would be getting us frustrating. Even if it is a push button and LED, we should have to do the same procedure. So here is the scope of a development board, which is having all of the hardware and circuitry already constructed on a PCB, makes much easier and friendly to experimentation and general prototyping. In development boards, all the GPIO and communication pins like UART, I2C, and SPA pins are free and accessible in a common point, so that we can connect any sensors and controllers easily. A typical development board consists of a power circuit as a power source, a microcontroller, which is the brain of the development board, a programming interface through which we can connect the board to the computer and code the microcontroller with IDEs like Arduino IDE, all the input-output pins, usually known as GPIO pins, and basic status LEDs. Okay, let's have a look on some microcontroller-based development boards available in the market. ARDUINO UNO. The ARDUINO UNO is a microcontroller board built with ATmega 328. It has 14 digital GPIO pins, 6 analog inputs, a 16 MHz crystal oscillator, a USB connection, a power jack, and a reset button. This board contains everything required to support the microcontroller. We can code and upload our program to this board using Arduino IDE by simply connecting it with the computer. Node MCU. The Node MCU ESP8266 development board comes with the ESP12E module containing ESP8266 chip. This microcontroller operates at 80 MHz to 160 MHz adjustable clock frequency. Node MCU has 128 KB RAM and 4 MB of flash memory. These boards can control the devices and sensors such as PIR, ultrasonic sound sensors, electrical appliances, network devices, etc. For example, using simple codes and libraries, you can control a bulb or any other devices in your home using your smartphone. So as a passionate techie, why not we can make a simple development board for our applications? Yes, Stickontech was working behind this and we are satisfied with the goal we achieved. So we will show you how we accomplished it. If you are interested to make like this, I am attaching all the details such as circuit design that I am using in this video is available in the description link below, or visit stickontech.com. Let's start from the scratch. The microcontroller we are using here is ESP07. It is a 32-bit microcontroller with 1 MB flash memory and inbuilt Wi-Fi. It comes in SOP package with a size of 16 mm by 21.2 mm by 3 mm. First of all, we have to design a circuit diagram with the proper component values and measures as shown. Once the designing completes, we can convert the circuit to its corresponding PCB. We are using ECEDA for circuit and PCB designing. In ECEDA, we can create a new project and sketch the circuit. If you are a beginner in ECEDA.com, check out the link in the description for how to design and develop PCBs using ECEDA.com. Let me briefly explain the circuit. Our microcontroller works in 3.3 volt. So a 3.3 voltage regulator IC-AMS 117 3.3 and its peripherals are provided in the power section. We are planning to power the board with a 5 volt supply. The basic circuit of ESP07 is already designed and a button is connected for resetting the microcontroller. For programming the ESP, we are using FTDI module, which converts USB to TTL serial. For that, ESP's UART pins are connected to a 4-pin header pin, so that we can connect FTDI module easily. All other GPIO pins are connected to two 6-pin header pins and labeled the pin number properly. Before uploading the program, the ESP need to be in flash mode. To enable this, we have to ground GPIO 0. A male header pin H7 is provided for this, and enable program by inserting a jumper between pin 1 and pin 2. Once the codes are uploaded, the jumper can be inserted into pin 2 and 3 for normal operation. Now our circuit is ready. Convert this schematic circuit to a PCB with the option provided in the menu bar. Place the components as you like in the space provided in the pink rectangle and route the tracks using PCB tools. We suggest auto router to draw the tracks instead of manual drawing. This will avoid routing errors. We can add text images on the board for labeling. So done now. Here is our final PCB and it has a size of 50 by 60 mm. We can check how it will look in 3D viewer. Now we have to generate its Gerber file for PCB manufacturing. We are making PCBs from jlcpcb.com. They are providing high quality PCBs in cheaper rates. If you are making PCBs from jlpcb.com, you can get 5 PCBs for $2. Upload the Gerber file . Normally the production will take 2 to 3 days. So here is the PCBs. It took only 10 days to reach. You can see the quality of the board, tracks and printing. How stunning it is, isn't it? So let's place the components according to our design and solder it carefully. Now connect a power source to the board. Here is our final product. Now let's test the board with a basic blink code. For programming, we have to connect a FTDI module to the FTDI pins provided on the board. This FTDI module you can get for $2. Turn off the power button and connect FTDI's power and TX RX pins. Make sure the RX pin of FTDI module is connected to the TX pin of our development board and the TX pin to the RX. Now connect the board to the USB port of your computer in which the Arduino IDE is installed. Select the board ESP generic module and set all the parameters as shown. Now select a basic code from the examples and upload. Yes, the uploading has completed. Now change the board from the flash mode by swapping the jumper and reset. See, our development board is working perfectly. This way we can connect different sensors and controllers with our board and execute our ideas. This type of boards are useful for tech lovers and developers. So, thank you for watching, and in the next episode, we will show you how to use this board with different sensors and how we can use this in our day-to-day life. See you on the next video.